Hello all. In our last session, we had discussed about the experimental research design in which we tried to establish the causal relationship between two variables. If at all in business research we are able to understand what is the cause and what is the effect, then it will help us a lot in decision making. In our last session we also discussed about the various conditions that are required for any causal relationship to be established. For example, concomitant variable variation, time order, occurrence of variables, and absence of causal factors. Now there are certain symbols that we use in designing experimental notation. First, in this session we'll be discussing about that only. First symbol is X, the exposure of a test group to an experimental treatment whose effect is to be measured. In experimental research design, what we do is there is a control group and there is an experimental group or a test group. So if we, for example, want to see whether eating an apple increases hemoglobin in the blood of school going children. So what we will do is we'll divide our sample into two groups. Divide school going children into two groups on which we are doing this experiment. One group will be given apple every day in the morning, and the other group will not be given. At the end of the month, we'll try to see what has been the effect of eating apple every day. Okay, so X is the exposure of a test group to an experimental treatment whose effect is to be measured. Here what was our experiment? Here the experiment was that eating apple actually increases the hemoglobin. Now another symbol is O, the measurement or observation of the dependent variable. And what is the dependent variable here? In our last session we also discussed about the things we use in experimental research design. First was independent and dependent variables. Okay, so the example that we took right now, we are discussing whether eating apple increases hemoglobin. So what will be the independent variable here? Independent variable would be eating apple and dependent variable would be increase in the hemoglobin. So O will be the measurement or observation, means after 1 month when we will see how much hemoglobin of the student who have been eating apple every day has increased. So that will be depicted by O. R will be random assignment of test unit or group to separate treatments. Like the group of children who are subjected to this experiment would be depicted by R. Now there are certain conventions that we have to follow. Movement from left to right indicates a time sequence of event. Okay, we when we write the experimental design, we'll see in our coming classes. When we write it, so when we are moving from left to right means the time has passed between the two symbols. Okay, all symbols in the same row indicates that subject belongs to the same specific treatment of group. The vertical arrangement of symbols means these symbols refer to the events or activities that occur simultaneously. All these things you will understand when we will actually see. Now, factors affecting internal validity. In our last session also we discussed about internal validity and external validity. Just to recapitulate, internal validity was when we are able to establish that whatever effect which is seen in the dependent variable, it has been caused by the independent variable. Okay, so when we want to establish an internal validity, we have to have certain factors. First is the history. It refers to those specific events that are external to the experiment but occur at the same time as the experiment. So this will actually affect the it will have an impact on the internal validity. Like, it refers to those specific events that are external to the experiment but occurs at the same time as the experiment. For example, we can say that eating apple, like the example we took, eating apple increases hemoglobin. But what if the weather is very nice, okay, then it is winters, and specifically in winters we tend to eat more, and and because of all these things the hemoglobin has increased. Means a good weather, okay, and good environment, okay. The students were not under any stress, they were enjoying their vacations, and that time the experiment was carried out. So they were having a very very healthy and relaxed lifestyle, so might be it was because of that that the hemoglobin increased. So it will have an impact on the internal validity. Maturation, it is concerned with the change in a test unit with passage of time. Like, if the experiment goes on and on and on, so the time has passed, and then the impact may also dilute. For example, this eating apple increases uh, the hemoglobin of blood. So if the experiment has been carried out say for 10 years, so the impact of a person 10 years after the experiment has started may have some kind of diluted output. Means we cannot say that, because now he has become 10 years older as to when the experiment was started. So this maturation, the time lapse, may also like meddle into the output. Then testing, when the respondents are beforehand exposed to the experiment, means they know that okay, they are under any experiment, so in turn it will have an impact on the output, which is not correct. Instrumentation refers to the effect caused by the changes in the measuring instrument. Okay, whatever method or whatever instrument we are using to understand the effect, it has to remain the same. Otherwise, it has an error. Like, if we are taking any instrument, then we can say that it has to be same, okay. Like weighing machine also, if we use a different weighing machine at different hospitals, we might have an error of a few kilograms. So this also has an impact on the internal validity. Statistical regression, it occurs when the test units with extreme scores are chosen for the exposure of the treatment. Like, if suppose the people, the sample we have chosen for this experiment, as it is they were having very very good hemoglobin, so it will not be like if they are having hemoglobin of 14, so the hemoglobin will become 20. It is not possible, okay. So as it is, it was very good, and then you are eating apple, and then you are saying the hemoglobin hasn't changed. So it was because they are in the extreme condition, okay. And on the contrary, like if a person is having very 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 low hemoglobin, seriously low hemoglobin, then we give only apple, and then we say still it is not normal. So such extreme cases should not be included in the sample. It should be like, sample should be an average normal hemoglobin, not too high and not too low. Only then we can establish the internal validity. Selection bias, improper assignment of test unit to the treatment. We have not chosen the sample properly, okay. Then environment might be different. External validity, what did we understand by external validity? External validity was uh, how impactfully we can generalize the output of our experiment. That becomes our external validity. What are the factors that affect external validity? First is, environment might be different. Like, if we say that eating apple increases hemoglobin, so it increases hemoglobin in India. It might have a different impact when the experiment is conducted in different experimental zone, like where it is too hot or it is extremely cold. So in that condition, this eating apple would have a different kind of impact, not as similar as it has in India. Okay, so environment should also be same, similar, not same, to have the same kind of impact. Then population might be different, definitely, and time lapse would be different. So these are the few factors that actually have an impact on the external validity. So till now we have understood what experimental research design is, how, what are the different symbols, and how the cause and effect relationship is established. What do we mean by internal validity, external validity? What are the factors that actually impact external internal validity? So that's all for this session. We'll continue in our next session. Thank you.